Welcome, everyone, to the Atheist and Christian Book Club. My name is James Walker. I'm co-founder and kind of co-host of the club. Our club was started, we've been doing this about 7 years now, and we are a monthly get-together, now almost always on Zoom. But we are a gathering of atheists and Christians discussing books, atheist books and Christian books. We try to alternate, do an atheist book one month, a Christian book the next month, and have respectful dialogue, conversation. And in most cases, including in this September issue, we do usually have the author of the book in question with us so that we can get it straight from the source. And our guest author today is Casey Luskin. And Casey is both a scientist and an attorney, has a graduate degree in science and law, giving him expertise in both the scientific as well as the legal dimensions of the whole debate over evolution. He holds a PhD in geology from the University of Johannesburg, where he specialized in paleomagnetism and the early plate tectonics history of South Africa. He earned a law degree from the University of San Diego, where he focused on First Amendment law, educational law, and environmental law. His BS and MS degrees in earth sciences are from the University of California, San Diego, where he studied evolution extensively at the graduate and undergraduate levels and conducted geological research at the Scripps Institution for Oceanography. Dr. Luskin has been a California licensed attorney since 2005, and he's one of the co-authors of this month's book, The Comprehensive Guide to Science and Faith, co-authored along with William Dembski and Joseph Hoden. He also was a recent guest on our ministry's Watchman Fellowship Apologetics Profile podcast, along with his Discovery Institute colleague, Kristen Marias. So, Casey, welcome to the Atheist and Christian Book Club.
Oh, thank you guys for having me. It's great to be with you all.
I'm one of the co-founders of the book club, and the other co-founder is Bill Cluck. Bill is a former Christian who became an atheist, but in the process of this 7 months, and especially the last, I would say, year and a half, he began going through a crisis of faith, or maybe a crisis of lack of faith, however you want to characterize it. But he is at the place now where we had a book club, what, 4 or 5 months? No, it's actually, I think, October or November of last year. It was about a year ago, where he announced for the whole club that he now does believe that there is a creator God. He's not a deist, he is a theist, but he doesn't know where Jesus fits into this. He's still working through that. He does, however, believe that God is both transcendent and immanent, and that my hope is, of course, I'm biased, being Christian, so my hope is that if the journey from atheism to Christianity is 1,000 miles, that maybe Bill's only a few blocks away from the destination at this point. But that's yet to be seen. My other job, my real job, is I'm president of Watchman Fellowship. It's an evangelical apologetics ministry focusing mostly on interfaith evangelism, and so issues of other religions and worldviews. So we're dealing with of course, atheism, the topic of the book club, but also with issues like Islam and Mormonism, Jehovah's Witnesses, and basically how can we as Christians build bridges and have constructive conversations with those that we disagree with. And Casey, I noticed in reading your chapters that it's I see a lot of parallels in this, because it is can be a lot of tension in these kinds of conversations, discussions. In fact, later I think Bill's going to have a little video of a little issue he got into, which was very reminiscent, especially of chapter 15.
Hey, defending the faith, James.
He trying to defend the faith, and he was kind of shot down by the Atheist Experience YouTube show. So, and Casey, we're going to ask you to give Bill some pointers on maybe how he can have a better conversation with that. They were polite, and I have seen a lot of snarkiness, certainly not from these guys, but that can happen. And as you pointed out in your book, it can actually happen on both sides of the equation. But whatever side you're on, we can be less than generous in our conversations, and we want to avoid that. And that's part of what we try and do in this book club, constructive dialogue. And over these 7 years, a lot of us have become friends. Some of us have been here most of that time, actually. And so, Casey, I want to welcome you, and I want to start with Bill. And Bill, can you kind of give him a background of especially the clip, and I'll pull that up when we're ready. But the clip that you want to look at, that it's like a 4-minute clip from, and the Discovery Institute was talked about in a negative way. I don't know, Casey, you might not know that. Sometimes you guys have a bad reputation, but we're going to let you try to defend your reputation a little bit on that, and just kind of give Bill some pointers. And in all fairness, I've listened to a lot longer than the 4 minutes. I haven't listened to the whole thing yet, but it comes across better from their perspective if you listen to the whole context. But there's this one part that Bill was definitely concerned about, and I'll let him tell you about that. Go ahead, Bill.
So here's the thing, Casey, is we had your boss, Stephen Meyer, on, and he said the chances of a protein forming from amino at just randomness is like 10 to the 70th. The cosmological constant with the expansion rate of the universe is like 10 to the 120th. So they go, I don't believe in these big numbers. So what would you say about using these numbers, these hugely improbable numbers, to make a case for God?
Well, first of all, that's great that you went on the Atheist Experience podcast. And Bill, that's obviously, that's not easy to go a bunch of folks that disagree with you. And I enjoy having these conversations. Little tiny background on me is when I was an undergraduate, I started a student club called the Intelligent Design and Evolution Awareness Club to try to bring together folks with different views on this topic, just to have friendly, rational conversations. And that's something that's very sort of a very near and dear value to my heart. Just that we don't have to agree, but we can have friendly civil conversations on this topic. And I think this is definitely one of those issues where reasonable people can and do disagree. That's fine. Like, we are not all going to come away at the end of the day agreeing on everything, or maybe agreeing on anything. And that's all right. Like, we don't have to agree on things to be able to have an interchange that helps us all come to a better understanding, me included in that. So as far as Steve Meyer is probably talking about a research paper that was published by one of our colleagues at Discovery Institute, Douglas Axe. This was a paper in the Journal of Molecular Biology, Bill, published in 2004, where he did basically what are called mutagenesis experiments on an enzyme called beta-lactamase, which is an enzyme in E. coli that helps to confer, antibiotic resistance, basically. And this is an enzyme of sort of fairly typical complexity. Its job is to cleave something and, break it apart so it doesn't do its thing anymore, from what I understand. So Doug Axe did empirical experiments on the beta-lactamase enzymes, mutagenesis experiments. And through those experiments, he was able to empirically derive this number, that the likelihood of sort of a random sequence of amino acids yielding a stable functional protein fold of about 150 amino acids in length, pretty typical size, is about 1 in 10 to the 77th power. And there's actually a wide range of studies that have looked at this question. What is the likelihood of a amino acid sequence giving you a functional protein? And I mean, I don't have these numbers exactly in front of me right now, but from what I recall, studies have come up with a number of different, a variety of different numbers. Anything from 1 in 10 to the 14th sequences is going to be functional to 1 in 10 to the 126th sequences is going to be functional. And it kind of depends on the enzyme and the way it works. But you could say that Doug Axe's result lands pretty squarely in the middle of the pack when you look at the variation of results from different studies that have done these kinds of mutagenesis experiments on proteins. And so it's fairly believable. Like, if you're in the field of protein mutagenesis, protein rarity, studying those questions. The idea that a random sequence, the likelihood of it giving you a functional protein is 1 in 10 to the 77th. That's not out of the norm for that field. So, I mean, I don't, if somebody says, well, I just don't want to believe this because it's a big number. I mean, I come from the field of geology, all right, where like we deal with deep time all the time. And you start to think about like really big numbers, huge amounts of time that have elapsed in Earth's history. And you kind of just get used to big numbers after a while, so it can be hard for the mind to sort of wrap itself around these big numbers sometimes. I do get that. I appreciate that. But these aren't just being pulled out of thin air. I mean, in Doug Axe's case, this was an empirical result. That was the result of mutagenesis experiments that he did. It got published in the Journal of Molecular Biology, a very well-respected, peer-reviewed journal. This wasn't just, Bob's creationist bookstore in wherever, Hickville, writing random numbers on the wall. Like this isn't a mainstream scientific journal. And this was actually research that was done, I believe, at a biology.
Well, let me sum it up, Casey.
Yeah,
so
go ahead.
You're saying there's a chance.
saying there's a chance, but it's a pretty small one. Yeah, there you go.
Since Stephen Meyer, your boss, was on, and we did the Dumb and Dumber thing.
The Dumb and Dumber quote. Yeah, it's a great classic line. Yeah.
Here's the other thing. Stephen wrote a book, The Return of the God Hypothesis, which we, did a thing on. And the Cambrian explosion was one of his evidences that points to God. So what is the likelihood that the, via echinoderms, chordates like us, that these sophisticated body plans would come about in such a sudden manner?
So I don't know if on that one, if I can put a number on that. What I can tell you, though, is that the data shows that the vast majority of the major living animal phyla appear abruptly in about a 5 to 10 million year window. In the Cambrian period, is about 520 to 530 million years ago. And some folks will say, oh, no, the Cambrian explosion was actually this very long event that took tens of millions of years. That's kind of the classic rejoinder to this. And here's what I can say, all right? I was actually Steve Meyer's research assistant when he wrote the book Darwin's Doubt. This was like in 2011, 2012. The book came out in 2013. About a month before Darwin's Doubt came out, there was another book that came out, which you guys probably may not have heard of this book. It's, didn't get as much fanfare as Darwin's Doubt, but it was by two leading Cambrian paleontologists named James Ballantyne and Douglas Irwin. And the title was The Cambrian Explosion, the Construction of Animal Biodiversity. And what this book basically did was it talked about the Cambrian explosion and whether or not it is a real event in the fossil record and whether or not it's just an artifact, of say poor preservation or the evolution of hard parts, or there's really this long fuse leading up to it. And what they basically conclude is that the Cambrian explosion was a real event in the fossil record. And here's what they say. They say, taken at face value, the geologically abrupt appearance of Cambrian faunas with the exceptional preservation suggested the possibility that they represented a singular burst of evolution, but the processes and mechanisms were elusive. Although there is some truth to some of the objections, we're talking about the idea that the Cambrian explosion, really took tens of millions of years, or it only represented the evolution of hard parts and wasn't an actual, burst of evolutionary novelty, et cetera, et cetera. So they say, although there is truth to some of the objections, they have not diminished the magnitude or importance of the explosion. And they say several lines of evidence are consistent with the reality of the Cambrian explosion. And they basically go on to affirm that the Cambrian explosion is about a 10 million year event in the fossil record where most of the major living animal phyla appear abruptly, these very diverse body plans, and it's a real thing. And this is not coming again from it's not coming from Stephen Meyer. It's not coming from Bob's creationist bookstore out in the Hickville. Okay, this is coming from two leading Cambrian paleontologists. And we were ecstatic, by the way, when this book came out, because we were like, oh my gosh, like, of course, these guys don't support intelligent design. Like, they don't support our interpretation of the evidence as far as intelligent design goes, but they do support Steve Meyer's interpretation of the fossil record, namely that the Cambrian explosion was a real event, 5 to 10 million years, and most of the major living animal body plans appear during that period. And so it really validated, some of the fundamental points that Steve Meyer was making in that book. So although I can't, put a number on it, Bill, what I can say is that I think the Cambrian explosion does pose a major challenge to a standard evolutionary Darwinian view of the history of life. Because I think Richard Dawkins has this quote where he says, it's as though they were just planted there without any evolutionary history, talking about the Cambrian animals. It's definitely the exact opposite of what you would expect from, a standard evolutionary model of origins. And I would say it's much more consistent with a large infusion of information into the biosphere, what we would expect from intelligent design.
So you and Professor David been in a little tit-tat about 80, you say 85% similarity between us and chimps. The standard's 98%, which is really fascinating that we have more in common with chimps than we have with gorillas, than chimps have with gorillas. Just an amazing statistic if it's true. So can't you just concede that us and chimps did have a common ancestor, 6-7 million years ago? Can you just concede that point? And look at the ERVs. Don't the ERVs, which show all these endogenous retroviruses are at the same place on the genome with us and genes, they use these big numbers too. They say the probability of that happened by chance is millions. So couldn't you just concede that point?
So as far as Professor Dave goes, I actually have not responded to his recent attack on me. I think his title was, he called me a fraud. I have not gone after him. In fact, I've never gone after him personally and attacked him personally. That's just not the way I do things. But I'm basing my, claim that we are really, the data shows we're about 85% genetically similar to chimps upon a paper that was published in Nature back in April by you et al. If you look at that paper, the data is very clear that we're about, if you add up basically what's called the single nucleotide variation, which is about a 1.6% difference, plus what's called the gap divergence, which is about a 13.3% difference, it comes out to about a 15% genetic difference between humans and chimps. And they actually also have another way of doing the analysis in that study that also came to about the same result. Fine. I mean, look, as far as the percent genetic similarity, what does it mean for this question of common ancestry? I've actually never thought that the percent genetic similarity, that raw number all by itself, is going to tell us very much about whether we do or do not share a common ancestor with chimps. And I've been very consistent with this, by the way. Going back, I was looking through some old blog posts. The first time I think I remember I could find saying this was back in 2008. And I've been saying this very consistently over the years, that I just don't think that the percent genetic similarity is all that useful a statistic for answering a lot of interesting questions. Now, a lot of my evolutionist friends out there apparently feel differently, because they will commonly cite, or they have commonly cited, that, claim that we are 99, 98% genetically similar to chimps. And then they have turned that into an argument for common ancestry. Bill Nye, the science guy, is obviously he's not a official PhD scientist, but he's a spokesperson for a lot of the way people think. He's got this quote that he says that we're 98.8% similar to chimps, and this is striking evidence for chimps and chumps to share a common ancestor. That's not an exact quote, but it's pretty close from his book, Undeniable. If you go to the Smithsonian Institution, you walk into their human origins exhibit, and in very, very large letters on the wall, it says, you and chimps, 98.8%, genetically similar. And it goes on to say we're 1.2% genetically different. So look, I mean, I don't really care what the exact number is. I mean, it is whatever it is, doesn't matter, doesn't really, in my view, it's not really answering many questions. If we turned out that we were 99 or whatever percent genetically similar to a chimp. That would be interesting. But those genetic similarities could be explained not necessarily just by common descent. I think that is one way to explain it. I mean, I don't think common descent is a crazy position. I think the common ancestry can explain, many of these similarities between organisms. But another way to explain the similarities would be common design, where we're built upon a common blueprint. And again, this is not something I'm just pulling out of thin air. When we observe the way intelligent agents design things, we see that they will reuse different functional modules in different design, or the same functional modules, I should say, in different designs or different systems to perform similar functions. Okay, so I'm sure some of you guys have done computer programming. I wrote many thousands of lines of Python code during my PhD and kind of got into that whole world. And I can tell you that, the first thing I would do when I'm going to write a new computer program is I find an old program I wrote and I hit copy paste. Okay, I make a copy of it because I'm going to use some of that code from a previous program to perform the function I'm going to need for the new program I'm about to write. And computer programmers will borrow code or reuse code or steal code, depending upon what they're doing, from other computer programs all the time in order to reuse functional components. So a lot of the genetic, we could understand the genetic similarities between humans and other species, whether it's chimps, gorillas, other primates, other mammals, whatever. We could understand those genetic similarities. Yes, common ancestry is one way to understand it, but you could also understand it through common design, where we're being built upon a common blueprint. We see genetic coding modules being reused to perform common functions in different organisms. Now, Bill, you raised a really interesting point. What about ERVs? Now, the claim with ERVs, and this really falls into the broader class of the idea of junk DNA, that there is DNA in our genomes that is not performing any function to help us survive. Okay, so notice that when I made the argument, the designers will reuse parts that work to perform, similar functions in different systems. Well, what if you have similarities that aren't performing a function, that aren't doing anything at all? Okay, so I have always, again, this is nothing new. I've always been very happy to acknowledge that if it's true that, we share large amounts of our genome with other species, and that's really not doing anything, it really is just junk DNA that is non-functional, that I think that probably a better explanation in that case would be inheritance from a common ancestor than common design, because it would be very strange for a designer to put, all this useless junk DNA in different organisms in the exact same place. I think that inheritance from a common ancestor would in fact be a better explanation if, and that's the key word here, if in fact that DNA really was functionless junk DNA. The problem for the junk DNA argument, and this applies whether we're talking about ERVs, line, sign elements, pseudogenes, other types of DNA that are said to be junk DNA that's shared across species, is as we are learning more and more about the genome, we're finding that the junk DNA argument is receding into the gaps of our knowledge, okay? The more we discover about the genome, the more we are discovering function. This is true, in fact, for ERVs. There have been studies that have found a variety of functions for ERVs. They are vital for the formation of the placenta during pregnancy. They're involved in regulating gene expression. They're also involved in some cases actually in immune system functions. And this is where it gets really interesting, because one of the main reasons that people will say, oh, ERVs clearly must be, just ancient viral insertions into the genome. They're retrotranscribed in the genome is because they look kind of like viral DNA. And I think I've even heard there's a couple examples where you can take the DNA from an ERV and express it and it'll produce a little virus, okay? So the question is, why do these, not in all cases, but in some cases, very, very, very high degree of similarity between these ERVs and viral DNA? Well, one of the functions of ERVs is actually to work with our immune systems to help fight off viruses. So one of the reasons for the genetic similarity between, what we call ERVs, but are really just coding modules, in my view at least, that help us to fight off viruses and do other things. one of the reasons for those similarities to viral DNA could be because they're involved in actually fighting off viruses, and they're recognizing and helping us to target viral DNA. And a lot of these ERVs are not exactly like viruses. They are, from the junk DNA perspective, they would say they've been degraded over time. So they no longer resemble viral DNA very closely, but they still have some general structure. But even those ERVs can have function. I don't know if you saw a debate that I did with Dr. Daniel Stern Cardinale, last year on a skeptics channel on YouTube, the Non Sequitur show. But he brought up, okay, well, yeah, there's all this DNA that looks like it's repetitive DNA, and it's derived from DNA that's supposed to be able to reinsert itself into the genome. But he said it's degraded so it can no longer perform a function. But during the debate, what Dr. Dan meant by function was he was presuming that the function is supposed to be its ability to hop around the genome. But it can perform, even these degraded repetitive DNA elements like sign elements, line elements, ERVs that are no longer able to hop around the genome, or they're not able to do that. They perform many other functions. They're often involved in regulating gene expression. They can function as enhancers, and they can actually be attachment points for promoters and things. They can do all kinds of interesting functions related to regulating gene expression and formatting the genome. So it's not the case that this repetitive DNA that maybe resembles ERVs or resembles transposable elements in certain ways, that therefore that's all it is. It's just a transposable element, or it's just an ERV. We found numerous types of functions, and there are many papers discussing these functions. So I think that the whole idea that we can just dismiss this repetitive DNA, these ERVs, as junk DNA, that there's the likelihood of it being in the same place is so low. Well, that argument is assuming sort of a standard evolutionary explanation. If it was designed to have a function, and in fact it was put in the same place in the genomes for a purpose to perform a function, then those likelihood numbers that people will come up with, they really don't apply to a common design type argument, because the designer is going to reuse parts. Yeah, go ahead.
So are the atheists, because I'll talk about the strong nuclear force, poly-exclusionary principle, things which seem to point to God, instead of being, well, that's a good point, they never concede a point. They just nothing. So are they, in Romans 1:20 it says they're repressing the truth in unrighteousness. Is that the case?
Well, I mean, I love to, I think you should concede points where the point is fair. Like, I think that you can explain functional genetic similarities through common design or common descent. They're both possible ways to explain many functional genetic similarities. Right. I think that if, in fact, the DNA is junk and it's shared in the same place, I think the common descent is a better explanation for that. All right. And by the way, you guys all know I'm a proponent of intelligent design. Intelligent design is not incompatible with common ancestry. So if it turns out that we do share a common ancestor with chimps, I mean, I'm not going to lose a lot of sleep over that. I mean, I disagree with it for scientific reasons, but I don't have like huge, life-changing reasons that I have to stick to being a skeptic of common ancestry against all evidence. I'm trying to follow the evidence where it leads here. So look, I don't like to stereotype people. I mean, atheists are human beings. They span a very broad spectrum. I've interacted with some atheists that are very willing to concede points to intelligent design, and other folks who are not willing to concede points to intelligent design. So I don't want to say, oh, all of them are just stubborn, hard-hearted folks, because I've met folks that are not like that from the atheist perspective. And I've met folks who are. And frankly, there's probably Christians that are hard-hearted and stubborn, and there's probably Christians who are very willing to concede points. I mean, we all have to work on ourselves and just try to be able to engage in good dialogue. Bill, I love, by the way, that you mentioned the Pauli exclusion principle, because I don't know if this needs to be talked about more, but it's a little known fact that the Pauli exclusion principle is the fundamental basis for all laws of traffic, because it just says that two, pieces of matter can't occupy the same space at the same time. That's why we have traffic laws. So anyway, stupid
Let me,
joke.
this might be a good point to actually, let's bring that video back in, kind of circle back around to that, because I've watched it a couple of times and I'm not exactly understanding the point that's being made, but it seems like on these high levels of improbability of the expansion rate of the universe being precise, give or take so much, or you don't even get the periodic table. They seem to throw a Uno card on Bill and just say Uno reverse. And no, given enough time, it is not only not improbable, it's 100% guaranteed to happen. And so I want to play this clip, and maybe you can help us make better sense of it and comment on it. So let's see if this will work here.
But no matter what your model is, right? But whether you have like a rubber band model or not rubber band model, if the universe is around forever, then it's just a guarantee that life will be produced at some point.
Could be.
Yeah.
So we're all treading water here because this is theoretical physics that is pointing people to God.
No, I'm sorry. I have to interrupt right here real quick, Bill. I have to interrupt because everything that we've talked about so far has just been statistics and not like theoretical physics necessarily. So like all of your arguments are just basically, oh, there's this giant number that when you take that as a likelihood or a probability of this universe existing, it is incredibly low and is therefore just as well impossible. And what we're trying to explain to you is that from a basic statistics and probability perspective, you're just wrong about that because due to how statistics and probability just works naturally, the likelihood of life developing in a universe is going to be 100%, especially when we're already here to be able to analyze it.
Well, okay, I understand what you're saying, but you're familiar with the Discovery Institute, what's the name? So what they say is a protein forming, the odds of these amino acids coming together, and you have the causality problem where they all have to be left-handed.
Okay, but Bill, unless you're going to tell me that it's a 0% likelihood, then it really doesn't matter.
Right. So, Bill, I just want to make sure we're clear on this.
Okay.
You keep saying that there's this thing and the odds of the thing happening is really high. And we've given you a bunch of reasons why it doesn't matter what the odds are. If the odds are 1 in 50 or 1 in 50 trillion, it still is irrelevant. Like the number of the odds is not relevant.
Well, if this is so clear, and he says the odds are 10 to the 77th, and the amount of protons in the universe is 10 to the 80th, so that's saying there's no chance, basically. That's what these guys are saying.
That's literally not it. No, it's literally not saying that there's no chance. It's just that it's rare. That's all that says.
Obviously, it's like Dumb and Dumber, so you're saying there's a chance. Remember, what's the chance? Oh, it would be like 1 in a million. So
I feel like I've explained this before. So the likelihood of it happening is 100%. Bill, the likelihood of it happening is 100%, but the likelihood of it happening at any one moment in time is that percentage that you're bringing up. So we're not saying that, it's going to happen right now. What we're saying is that it will 100% happen at some point. That's what we're saying.
100%, you're saying. You're 100%, right?
That's how likelihoods work, yes.
Yeah, okay. So what I'm asking you, John, you've made a great argument. It's very compelling. So why doesn't the Discovery Institute say, "Oh my gosh, I heard this on John's articulation"? What are we talking about? Why are we using these big numbers?
So the Discovery Institute is a heavily biased think tank that is definitely geared towards a very creationist, fundamentalist sort of view of science and everything. So You're basically giving me a creationist source here and telling me, well, why don't the creationists admit this? Because they're not going to admit that. They're going, because the basic playbook of creationism is to twist the information into straw men so that it can convince people of things that are not reasonable. That's any creationist argument will fit that particular mold. And everything that you said here, as far as like the creation or the Discovery Institute goes, is exactly that.
Casey, we talked about this before yesterday, where Intelligent Design Discovery Institute is thrown under the penumbra of the creationism. So there's a lot of things you can respond to in that clip if you want to. I was fascinated by the assumption on John's part there that it's 100% that anything is going to happen at some point, and they're assuming an eternal multiverse or an eternal universe where matter just continually recreates itself. So wherever you want to respond to that, by all means.
Sure. I mean, there's a lot to unpack there. I'm going to just kind of ignore the personal attacks and the, I guess the genetic fallacy arguments that are being made there, because I wanted to stick to the substance. So exactly what you just said, Daniel. I mean, I think the core issue there is that he's assuming that we have infinite time. All right. And of course he's right. If there's infinite time, then yeah, I mean, I suppose you can do infinite things in infinite time, but all the evidence shows that we don't have infinite time. I'm not aware of us having infinite time in this universe. So I don't know how he justifies making that assumption that we have infinite time where the likelihood of anything happening, regardless of the unlikelihood, somehow becomes 100%. There's multiple lines of evidence that show that our universe is finite. I mean, number one, when Einstein first produced his theory of relativity, it predicted the universe was finite and it had a beginning. Then you had Hubble, who, of course, observed the galaxies and found that there was a shift to a longer wavelength spectrum of light, the red light shift. And that, of course, indicates that the galaxies are moving away from each other. And so, as the old story goes, if you were to rewind the motion of the galaxies, they would reduce back to a single infinitely dense point in space and time, what Stephen Hawking called the singularity, and you would get a beginning to the universe. The universe looks like it had a beginning. And then, of course, those observations began to lead to the formulation of the Big Bang model, which, of course, says that the universe is finite in space and time and had a beginning. That model predicted a very interesting thing called the cosmic microwave background radiation, which would be this leftover radiation from the Big Bang. I'm sure I'm not telling you guys anything you don't already know here, but I'll just say it anyway, and then that was discovered, that cosmic microwave background radiation was discovered in the 1960s. And then in the 1990s, NASA put up a satellite that confirmed the cosmic microwave background radiation to a very, very precise degree of the exact, frequency of the EM radiation we should be finding from that. And you had like Time magazine at that point running covers stories that said things like, has science discovered God or something along those lines, all right? Because we had seen the beginning of the universe and we confirmed it to a very, very precise degree. So as far as I'm aware, the best scientific evidence shows that the universe had a beginning. That means that time is not infinite. And I'm sorry, like maybe they want to look at the multiverse. That's all, we can actually grant that in this particular conversation about the origin of proteins. I'm pretty sure that, when new bubble universes pop into existence or whatever multiverse inflation model they're going to use, it's not incorporating proteins from pre-existing universes, okay? Whatever proteins exist in this universe, even if it came from some ensemble of multiverses, you still had to generate those proteins in this universe, okay? You've got to account for proteins using the probabilistic resources that we have in this universe alone. I don't think that the multiverse or whatever predated the Big Bang, we could debate that all day, could be happy to do that. But, you know, I don't think any of that is going to help us explain the origin of a protein. Okay. To explain the origin of protein, you need to look at the relevant probabilistic resources. And this is how science works. Okay. Science looks at the relevant, you know, explanatory tools to explain a given observation and the probabilistic resources that are available. And if the probabilistic resources simply aren't there to explain a data point, then you don't appeal to the model that lacks the probabilistic resources it needs. Okay. So when this gentleman was claiming that unless it's a 0% probability, it's irrelevant, I'm sorry, but that is simply not how science works. I mean, I did in paleomagnetism in my PhD, we would often rule out particular explanations, particular, you know, theories or hypotheses, because the data did not meet a certain statistical level of likelihood. Now, we didn't have to get a 0% probability to rule it out. That is not how anybody does statistics. I'm kind of mystified at that comment that he made. You have
Casey, would the argument also work in reverse? I mean, if however improbable God is, 1,000,000,000 to 1 odds, given enough time, 100% God must exist. I mean, I don't understand why the argument doesn't cut both ways.
And well, then also too, Casey, just to add to what James just said, getting back to this infinite time idea, that they have a problem in this universe of entropic decay, which is what your field is so keenly tuned to in geology, that without entropy, you can't date rocks because stuff decays. And you look at the atoms in the nucleus of physical things, and you know that there is a decay, and it cannot be that matter and energy has existed forever. And so there's a couple of problems with, as what James just said, with entropy. And then if anything can happen, then at some point in time in the universe, all religions are true or something.
I suppose, I mean, if you're going to say that, you know, if given enough time, could God exist? I mean, this gets into the question of where does something like God come from? And of course, the classical theistic view is that God has no beginning. God is, by definition, sort of the uncaused cause at the foundation of your worldview. So I don't even know if it's reasonable to talk about God coming into existence, but let's just stick to the protein thing here. And you guys are making really good points, though. I mean, we can do the math and ask, what are the probabilistic resources through our studies of science, through our studies of nature, to see if there is sufficient time and opportunities to generate a functional protein that, you know, requires 1 in 10 to the 77th chance of it coming about by chance. Okay. And so, for example, let's grant life. Okay. Let's grant that life exists. And let's say that every single organism that has ever lived on the face of this planet was given a random sequence of 150 amino acids in hopes of generating that functional protein fold, okay, where only 1 in 10 to the 77 sequences is going to do the job. Now, we can look at what is called biological probability bounds. These have to do with, you know, how many organisms have lived over the entire history of life on Earth, or how many cells actually have lived over the entire history of life on Earth. You can take into account all the cells that have lived. And if every single cell, well, again, we're giving this ridiculously generous assumption to evolution, every single cell was granted 150 amino acids, random sequence, hoping to get you this 1 in 10 to the 77 sequence that you need for a functional protein. Only about 10 to the 40th cells have lived over the entire history of life on Earth. You can look this up. This has been published in the literature, okay? So we are short by about 10 to the 37th trials. Even if we grant this incredibly generous assumption to evolution that every cell that ever lived is granted this 150 amino acid sequence, random, you know, mix it up each time, hoping to get that particular functional protein, you would still be short by 10 to the 37th trials, okay? Because we've only had 10 to the 40th cells that have lived over the entire history of life on Earth. So we do not live in a universe of infinite probabilistic resources. William Dembski sets what's called the universal probability bound at 10 to the 150th. And the way he basically determines that is he looks at the number of seconds that have existed in the universe, multiplied by the number of the basically Planck time, multiplied by the number of elementary particles that exist in the universe. And basically, if every elementary particle was interacting with every other particle at every moment of Planck time over every second of the universe, you basically have time for 10 to the 150th events to take place. Okay. Now, of course, we don't have to take such a broad probability bound to address biological questions. We can address them through the relevant biological probabilistic resources, such as the number of organisms that have lived. Doug Axe did another research study where he actually looked at the population genetics of how many organisms. Oh, the question he asked was, how many mutations could arise in a very large population of evolving bacteria over the entire history of life on Earth? And let's say that you have a trait that requires X number of mutations before it gives you some selective advantage, okay? So you're going to have neutral mutations accumulating, but eventually when you get the right number of mutations, you get a selective advantage. What is X? What is the highest number of X, the number of mutations you can get in a large population of evolving bacteria over the entire history of the Earth? And what Axe basically found was that if a trait requires 7 or more mutations before it gives you a functional advantage, that even, that trait could not evolve when you're giving evolution its best shot. A population of bacteria that's very large, evolving over the entire history of life on Earth. This is a sort of a best case scenario for evolution because bacteria have very large population sizes, very short generation times, very high mutation rates. If there was ever an opportunity for evolution to be able to generate, a new complex trait, that would be it. But Axe crunched the numbers and found that if a trait requires just 7 or more mutations before giving you an advantage, then that kind of a trait cannot evolve under standard evolutionary processes. So what we're seeing is that, we don't have infinite probabilistic resources to generate things on this planet or, in this biosphere or in this galaxy or in this universe. There's limits. And so you can't just say, anything can happen because the universe, is infinite in time and resources. That's just not the case.
So is there any hope for conformal cyclic cosmology, Roger Penrose's thing, that the dying embers of the old universe can spawn another universe?
You are now getting outside of my area of expertise, Bill. And so I don't want to speak to Roger Penrose's model when it's not something that I've looked at or studied very much. I can tell you that 2 of my colleagues here at Discovery Institute, that evil, as he's put it, creationist fundamentalist think tank, which is not true. 2 of my colleagues here, Dr. Brian Miller, who's a PhD in physics, and Stephen Meyer have actually another one of my colleagues, Dr. Bruce Gordon, who has a PhD in philosophy of physics. The 3 of them have been looking at Penrose's model in great detail lately. And I can tell you they're going to be coming out with some responses very soon on that question. And they're convinced that it can't be. By the way, getting back to, the idea that Discovery is a creationist fundamentalist think tank. I mean, I have colleagues at Discovery who don't even consider themselves to be religious or certainly are not Christian fundamentalists. In fact, just before I came here, I had, very lovely 45-minute conversations with one of my colleagues at Discovery Institute, David Klinghoffer, who is Jewish and certainly not a fundamentalist creationist. He takes a very different perspective on interpreting the Bible from his Jewish perspective than many Christians do. So this is just folks, making attacks that are not valid.
I wanted to circle back around on that as well, because that came up and you addressed it in your book as well, that the atheist experience, they were conflating creationism with ID, but Christians make that mistake too. So could you help us just get some definitional distinctions between the two and maybe how one is doing something from a totally different direction than the other for different purposes?
Sure. So creationism basically starts with a religious text. and then tries to find whether or not or how you can fit the scientific evidence with that religious text or that interpretation of that religious text. So you have obviously the classic view is young earth creationists who believe that the book of Genesis teaches that the earth is only, 6 to 10,000 years old or something like that. And they then try to go out and find scientific evidence that they claim shows that the universe and the earth are only 6 to 10,000 years old. You have old earth creationists who believe that, the Bible allows for a billion-year-old universe, but then they'll try to explain how the order of events in the history of life on earth and the universe fits with Genesis 1 or whatever, okay? So that's a view that is trying to, starting with a religious text, and then it's trying to go out and look at the scientific evidence and try to fit those things together. Intelligent design is very different. Intelligent design is simply starting with the data. And it's asking the question, what does the data tell us? Using the scientific evidence, can we find evidence for an intelligent agent being a cause that is responsible for many aspects of life in the universe? So the definition of ID that I like to use is that intelligent design is a scientific theory which holds that many features of nature are best explained by an intelligent cause, because in our experience, intelligence is the cause of their informational properties. So you guys all read the chapters, but this is basically a positive argument based upon finding in nature the kind of information and complexity which in our experience comes only from intelligence. And so, of course, if you guys, recall that kind of information that we use to detect or identify intelligent design is called complex and specified information. And roughly speaking, something is complex if it is unlikely, and it is specified if it matches some independent pattern. And so like right now, what's coming out of my mouth are very, very complex vibrations of sound waves, which is then being transmitted, through the internet and coming out through your speakers. You guys can hear them, but it's a very unlikely pattern or unlikely sequence of vibrations that you are hearing right now. But they also happen to match a pattern, namely words that you recognize from the English language. So instantly you would recognize that this was designed. But if what was coming out of my mouth was, the kind of fuzz that you hear when you turn on your old TV, you would not necessarily say, okay, he's trying to say something sensible right now. Or you would maybe think that there was a problem with my microphone and this was not an intelligently designed signal. It was just random fuzz. So we can detect design by looking for things that are both complex or unlikely and specified, meaning that they match a pattern. And this may sound strange at first, but from my experience, the more that I have used this criterion of looking for specification and complexity, I've really found that it works quite well for detecting design. There are some things that are specified, some things that are complex but not specified. We don't detect design. Other things are specified but not complex. We don't detect design. Think of like picking up a random bag of dirt, okay? A random bag of dirt is very complex. There's a lot of unique molecules in that bag of dirt taking on very strange shapes, very, very unlikely shapes, collections of, molecules and things in that. But if you just have a random bag of dirt, yes, it's unlikely, but there's no pattern that it's going to match to tell you that there's some design to it. But then you think of like a crystal from geology. I always keep rocks near my desk here. So here's a rock. If you look at rock crystals, they tend to be, patterns of repeating sequences of molecules over and over and over again. They're highly specified, but they're actually not complex, because given the right chemical conditions, say a pool of magma with a particular composition that is cooling below its freezing temperature, it will then start to crystallize, and the laws of chemistry and geometric packing of atoms will dictate the crystals that form. So given a particular, chemical composition of magma cooling below its freezing temperature, you are actually guaranteed to form particular types of crystals. And so this is no longer unlikely. It might be specified and then it has a repeating pattern. These crystals are highly ordered structures that have repeating patterns of atoms over and over again, but they're not actually unlikely. Given the right chemical conditions, you are guaranteed to form those crystals. So again, we're not going to detect design simply by finding a raw crystal. But then, you know, what do you find in life? Well, what's interesting is that the origin of life theorist Leslie Orgel, he actually gave the exact examples I'm giving right now. He talked about sort of a random glob of carbons being complex but not specified, and a crystal being specified but not complex. But then he went on to say that life is characterized by its specified complexity. And I think that the example of this protein that we've been talking about is a great example. You have in proteins very unlikely sequences of amino acids that match the exact patterns that are necessary to give you a functional protein. Okay, so we see complex and specified information in life, in living organisms. In our experience, complex and specified information always comes from intelligence. So we find in life the very type of information which in our experience comes from an intelligent mind or a personal agent. So I'm making this argument right now. I mean, you know, folks can disagree with this argument. You may not like it. You might pick holes in it. That's fine. But as I'm making this argument right now, I'm not invoking God or religion or some biblical text. I'm not saying that, you know, I believe this because the Bible tells me so. I'm saying this because this is a scientifically based argument. We observe that intelligent agents produce high levels of complex and specified information. We then predict, you know, the scientific method, observation. We then hypothesize or predict that we'll find high CSI in nature. We can then do experiments, the next step in the scientific method, and we can discover that structures like proteins are very rich in CSI. So then this leads to a conclusion that these highly complex and specified proteins were intelligently designed. And of course, like any scientific theory, we hold that conclusion tentatively, subject to future scientific discoveries. So again, I'm making this argument based upon science. So that right there is a key distinction between ID and creationism. Creationism starts with a religious text. Intelligent design starts with the scientific evidence using the scientific method. One last point on this, because this is an important question you guys have asked, and I appreciate you guys asking it. Creationism also then goes beyond what the science tells us and tries to address larger religious questions about, say, the nature or the identity of the designer. Intelligent design as a science does not claim to be able to answer that question of who the designer is. So, you know, if we look at the information in our DNA that encodes these highly complex and specified proteins, that might be, you know, I would argue that that is strongly indicating an intelligent cause. But that DNA itself doesn't say made by Yahweh or made by Allah or made by Buddha or made by Yoda or made by whoever you might think the designer is. It's just a highly complex and specified language-based code that is indicating the need for an intelligent cause to explain it. If you go further and say, okay, I believe that the designer is the God of the Bible, that's fine. You can do that. I mean, I believe the designer is the God of the Bible, but I make that conclusion due to religious reasons that are outside the theory of intelligent design. And I'm not claiming that intelligent design actually leads us to that conclusion. All intelligent design does is lead us to the conclusion that there was an intelligent cause at work to produce this feature that we're observing. So ID as a science stops short of getting into those theological questions, whereas creationism does. So that, I think, is another important key difference.
Well, speaking of a
Let me say this real quick,
question.
Bill. Just a second. I did forget to announce earlier. Others might have questions right now, and we have a text. If you have a question, would like to get up there and ask your question directly, or if you would rather have one of the moderators ask the question for you. On my screen, it's in the bottom of the left-hand side. There's a chat button, and go in there, and either Daniel or Brady1 will tell you that unmute. It's time to get ready for your question. We want to give other people a chance to talk about that. But what you want to, yeah, go ahead, Bill. Go ahead. You can.
I just had one last question, Ken. I want to hear yours. Well, let's ask a personal theological question. 3.5 billion years ago, you have a first prokaryotic cell. It takes 1 billion years. God's going, gosh, I cannot solve this problem. Oh, nucleus. That's right, eukaryotic. So after 1 billion years, we get eukaryotic cells. Now, I'm a theist now, so I'm believing God. But then it takes 2 billion years to echinoderms, chordates that'll lead to humans. That's a pretty good idea too. Let's do this Cambrian thing. But it takes, and then let's just blow it all up. 200 million years. You have the Permian, then the Cambrian, and I don't know, the KT extinction. So why did God take so long? And do you believe in an interventionist God?
That's a great question, Bill, and it is a very, very interesting question. I'll put on my theological hat here. It's a good theological question. I think a good theological question deserves at least my best attempt to give it a theological answer. Because again, I'm a geologist and I'm an old earther, old universer. So I accept these billions of year ages. I don't find any theological problem with that in my Christian worldview and blah, blah, blah. So my view as a Christian is that God experiences time very, very differently from we do. And we can quote that famous verse. I think it's in the Psalms. It says, for the Lord, 1,000 years is like a day, and a day is like 1,000 years. And that verse might be a little bit cliche, but I actually think it's speaking to a very profound truth, that God does not, it's saying that God does not experience time in the same way we do. Some folks have said that God exists outside space and time. So to talk about time for God is to talk about something that's like different dimensions, So I don't worry about that question very much because from God's perspective, time is just not an issue. Now, on the other hand, we can see that there were some interesting things happening on the earth. Like we have this idea of the boring billion, where there's like 1 billion years. I think it's like 2.5 to 1.5 billion years ago, where they're like, did anything happen? Well, actually, yeah, the world was largely single-celled prokaryotes during that time. But those prokaryotes, they were making a lot of oxygen. And that's a good thing. They were converting. So what was happening basically was volcanoes were erupting, spewing carbon dioxide into the atmosphere. And a lot of things would happen to that carbon. Some of it gets locked up in rocks. It ends up dissolving, going into the ocean and forming limestone. Other carbon goes into the atmosphere. Okay. Some of it just dissolves into the ocean, blah, blah, blah. But a lot of that carbon, that CO2, I should say, all right, that CO2 that was being expelled from the volcanoes over eons and eons of Earth's history was being consumed by those boring little useless prokaryotes who converted it into oxygen, which made this atmosphere we have today that is very friendly for complex multicellular life. Now, God could have just gone poof, if he wanted, and made an oxygen atmosphere. But I think that we see that God was preparing the biosphere for the eventual coming of human life. And maybe there's something after us too. I don't know, I don't know where it all goes in the end, but I don't claim to have all the answers, but certainly we can see that if you're looking for some theological reasons, that there certainly Earth was becoming more and more friendly for advanced beings that could love God and have a relationship with him, which I think is part of what he ultimately wanted, because God is a loving being. And ultimately he wanted to create beings that could have a relationship with him. Again, this is all theological, so I'm not claiming that I can prove this to you scientifically, but I do think it works to some extent as an answer here. It's a great question you asked, though.
Well, thanks for helping.
Yeah, we've got a question from Ken Daniels. Ken's a longtime good member of the club and my friend. So Ken, do you want to engage a little bit with Casey? Unmute.
I don't even know. Oh, am I mute?
No, you're okay. I think you're.
Yeah, I don't even know where to start. I'm completely outnumbered here because I'm probably the only person in the room that accepts evolutionary theory. And I, formerly a Christian missionary in Africa, actually. I'm a lay person, interested lay person. I don't claim to have any expertise in the subjects we're discussing. I've read a fair bit over the years, more in the past, 20 years ago, I was really heavy into it because that's when I was going through my crisis of faith, and so I read a lot of books on both sides. Behe and Dembski and you name it, all the big figures. Kenneth Miller, and you mentioned in your book as well. And so I have a lot of interest in it, but honestly, I really couldn't probably tell you anything or bring up any points that you haven't already been exposed to, given your extensive work in the subject. But just a couple of things on, I think that the impression I got when reading your chapters is that, oh, here's all these positive evidences for intelligent design, and somebody who hadn't been exposed to sophisticated evidence for evolution might conclude, like a typical Christian in a pew would probably read your chapter and come away thinking, oh, those crazy evolutionists, why do they even believe it? It's just, hocus pocus. There's no evidence for it. One article I read on Talk Origins is 29 evidences for macroevolution, and that was one of the things that tipped me in favor of accepting evolutionary, at least common descent. The whole question of how, the mechanism, and there's the fact, there's the fact of common descent, and there's the mechanism, two different things. I'm interested to know why, and this is maybe a psychological question, why you think somebody like Michael Behe accepts common descent, given that he is an advocate of intelligent design, is in your camp in a lot of ways, but yet accepts what I consider very strong evidence for macroevolution, at least the fact of macroevolution, not necessarily the naturalistic mechanism for it. I read his book, The Edge of Evolution. He made a pretty good case for common descent in that book. So I'm just wondering to know why, if there's no real good evidence for it, if the evidence is really just lacking completely, what compels somebody like Behe to accept it as a Christian?
Wait a minute.
No, great question, Ken, and nice to meet you, by the way, and thanks for sticking around here. If you're the only evolution supporter, I appreciate you being here. Can I ask, and if you can't answer this, but where did you live in Africa when you were there?
We were in Niger,
Wow.
Eastern Niger. The mission headquarters is based in Niamey, the capital, which is 3 days drive from where we were allocated out in the east.
Wow.
Desert. So
wow, that sounds very, very rural.
Yeah.
Wow,
sure.
That's amazing.
We weren't there terribly long. It was like 3 years before my crisis of faith intervened.
3 years living in an environment like that is a long time. When Westerners, we don't.
We had three little kids in cloth diapers at the same time.
Oh my gosh, that's amazing.
Toilet and stuff.
Oh my goodness, wow. I mean, us Westerners, we're not used to that kind of a life, I mean, so my wife and I lived in South Africa. We were in Johannesburg for about 4.5 years. Oh, yeah. And, obviously that's a very urban metropolitan environment, but even there, like coming from America, it's different, it's just, you learn to adapt, but adapting is not always easy.
We were with Wycliffe Bible translators.
Okay.
Learning the language there, a local language there, to
wow.
translate the scriptures into the language.
Wow. What an experience. So first of all, to answer your question, I really appreciated you distinguished between the question of the fact of common descent and the question of the mechanism. And that shows that you really are very, well read on this issue, because a lot of folks don't even get that distinction. Obviously, Behe makes that distinction. So you said you read Behe. That makes a lot of sense that you appreciate that point. So look, I mean, I'm good friends with Michael Behe. I've known him for many years. I first met Michael Behe when I was an undergraduate at UC San Diego. He came to speak, And I volunteered to babysit him for like an hour, a couple hours in the afternoon at the campus coffee shop, because this was in 1998. And, you know, they needed students to help out because he was speaking that night. And I eagerly raised my hand because I'd read Darwin's Black Box during summer between my freshman, sophomore years in 1997. Anyway, blah, blah, blah. So I've known him for a long time. And I've had these conversations with him. I mean, I think Michael Behe is convinced. And again, I don't want to speak for him, but I'm just going off what he's written and what he said publicly, you know, like in The Edge of Evolution, I think that his main reason for accepting common ancestry kind of comes down to like certain things like pseudogenes that are shared in different organisms. And he seems to think that, you know, they are functional. If they are functional as junk DNA, which I suppose does agree with that, then common ancestry would be a much better explanation. And again, on that point, I would agree with him that if they are functionless pseudogenes that are shared across species, then I agree with him that that would be a better explanation. I haven't had this conversation with Mike for a long time. I'm not assuming that he has changed his mind, Ken. But I honestly, I haven't talked to him about this in years. But I will say this, that in the last 10 to 15 years, there has been a slew of, so Edge of Evolution was written in 2007. And I will say that since that book came out, we have literally seen a paradigm shift in the scientific community on the question of junk DNA. Okay. In fact, there was a paper that came out in the journal Bioessays 2 years ago that says that we have seen a Kuhnian paradigm shift away from the idea of junk DNA. Okay. And what about pseudogenes? I mean, there's many different types of genetic elements. Pseudogenes are just one type. That's, I think, what Michael Behe finds persuasive. So pseudogenes, there have been a number of studies that have found function for pseudogenes. Now, of course, there are many pseudogenes where we haven't found a function yet. And so I would argue on those, the jury is still out. My story really briefly on junk DNA is when I was part of that student club that I started as an undergrad that I mentioned, we would make arguments, you know, for and against ID, and we would get hit over the head with junk DNA. This was in the late 90s and early 2000s. Okay, Ken. So like we knew a lot less about the genome back then. And this was even before the Human Genome Project was completed. I think that was completed like 2002 or 2003. So even before then. And what I would say is, look, rather than assuming that these genetic elements that we don't know what they're doing are junk, let's, you know, have a wait and see approach. Let's wait and see what the data shows. Intelligent design would predict that our genome is not largely junk. Evolutionary theory folks generally have predicted that it's largely junk. And so let's just see where the data lands in the end, because we don't know enough yet to make a decision on this question. So that was back, again, late 90s, early 2000s. In the mid 2000s, we started to see more and more papers starting to come out finding function for junk DNA. And then in 2012, something huge happened, and this was called the ENCODE project. You've heard this. ENCODE basically found evidence of biochemical activity for over 80% of the genome, or about 80%. And folks will say, well, does that mean that 20% of the genome is still junk? Well, one of the lead ENCODE researchers basically said that as we study more and more cell types, he expected that 80% number to go up to 100%. What did he mean by that? Well, what ENCODE did is it studied about 147 different cell types in the human body. And it turns out that many of the genetic elements in our body, they're only functional in certain cell types at certain stages of the human life cycle. So if you want to see them being, you know, functionally active, you kind of have to catch them in the act. You got to be looking at just the right place at just the right time, because a lot of them are only, you know, regulating certain things at certain stages of the of the human life cycle. So again, they studied about 147 cell types in the ENCODE project. But, you know, there are thousands of cell types in the human body, and certainly they were not studying human embryos in ENCODE, right? There's some ethical issues that come from studying human embryos in utero. And so there's a lot that we still don't know about what's going on in the human genome, especially in early development of human beings. And we know that a lot of these junk DNA elements are active in during those early developmental stages. A lot of that has already been revealed. So long story short here is there has just been a flood of data, I would say, since Behe wrote The Edge of Evolution, that I think pushes back on this idea that junk DNA really is functionless. Let me give you a cautionary tale from pseudogenes specifically, all right, against assuming that they are junk DNA. You guys have all heard of the Dover trial, right? My first assignment, by the way, this is kind of funny. 3 days ago was the 20th anniversary of my first day working at Discovery Institute. Now, I have not worked at Discovery for 20 years because I left for about 4.5 years when I went to South Africa and did my PhD, and I was not working for Discovery during that time. But one of my first assignments in September of 2005, when I first came to Discovery, was actually to go and observe the Dover trial in person. That was when it started in September of 2005. And I remember hearing the opening expert witness for the plaintiffs in that case was Ken Miller, very well-respected biologist. Ken, if Ken Miller was here, you wouldn't be alone. You know, he's very much a very strong defender of evolution and a very smart guy. And, you know, he's
a Christian.
And a Christian. He would call himself, I believe, a Roman Catholic. I'm not here to doubt his Christian commitment. You know, he would call himself a theistic evolutionist. So that's where he's coming from, right? Yeah. So at the Dover trial, Ken Miller testified. One of his opening arguments was about the beta globin pseudogene. And the beta globin pseudogene is a pseudogene that is shared by humans and chimps and gorillas, okay? And I don't have the exact quotes in front of me. I guess I could dig this up if I really wanted to. But Ken Miller said that the beta globin pseudogene is functionless, okay? So actually, I'm gonna dig this up here, okay? So, okay, here we go. He said that the beta globin pseudogene is, quote, broken. And this is during his Dover testimony. Broken, and it has a series of molecular errors that render the gene non-functional. All three of these species, talking about human, chimp, and gorilla, he says have matching mistakes, leads us to just one conclusion: common ancestry. And then he wrote a book the following year called Only a Theory, where he said the gorilla and chimpanzee pseudogenes have exactly the same set of molecular errors. In a court of copyright law, any motion that a designer could claim originality for the human genome would be tossed out in a flash, okay? So how has this argument sort of fared over time? Well, 2007, 2 years later, Eugenie Scott is giving a speech at the American Museum of Natural History. She actually critiqued me during the speech. It was a long time ago, but she was, and if you don't know who Eugenie Scott was, she was the former executive director of the National Center for Science Education. And I think the journal Nature once called her the nation's leading Darwinist or something to that effect. That was their words. So she said the beta globin pseudogene during the speech isn't going to do diddly. It's just going to sit there and not do a thing. She says the pseudogene is, quote, not going to function, not going to do anything because it is, quote, an inert gene, okay? So what I would have cautioned at that point would have been to take a wait and see approach. I would have said, look, you're assuming it doesn't do anything because you just we haven't researched it yet. We don't really know that this is in fact junk DNA, useless genetic junk DNA, the pseudogene. So a few years later, this was, I believe, in 2013, there was a paper that came out in the journal Genome Biology and Evolution. And what it found is that when it compared this beta globin pseudogene in these different primates, you know, human, chimp, gorilla, that these pseudogenes are more similar than they ought to be if they really were just junk DNA and were therefore accumulating random neutral mutations at a constant rate over time, okay? They're more similar than they ought to be. And what that suggests is that there is some function that these pseudogenes have that is basically causing them to weed out mutations. It's what's called purifying selection. And they said that, quote, in this paper, they said that there are strong functional constraints underlying the decreased contemporary diversity. So basically, this function is preventing these pseudogenes from accumulating mutations. Now, at that point, they did not identify what that function was. They just said that these pseudogenes, you know, statistically speaking, when talking about statistics, statistically speaking, they were more similar than they ought to be if they were really functionless and therefore could accumulate random mutations at a neutral rate. But they didn't know what the function was. So then a couple years ago, actually what happened was the American Museum of Natural History, I think this was in 2021 or early 2022, it might have been. They posted Eugenie Scott's lecture on their YouTube channel. They went into the archives, they posted on the YouTube channel, and I watched this and I was like, huh, I never saw this. She was attacking me. She was attacking lots of people, but I thought, I wonder if anything new has been discovered about the beta globin pseudogene. So I did a little bit of literature searching, and lo and behold, I found that there was a paper that was published in the journal Developmental Cell in February 2021. And this paper found that this beta globin pseudogene, quote unquote, is essential for erythropoiesis. What is that? That is the production of red blood cells. It basically said that this pseudogene is essential and quote unquote indispensability for producing human red blood cells. Okay. So we now know that this pseudogene that Ken Miller testified at the Dover trial was non-functional, and that Eugenie Scott spoke at the American Museum of Natural History claiming that this is not going to do diddly. It's non-functional. Today in 2025, we actually know that it is functional, and we know what the function is. It is essential for producing red blood cells, okay? So to me, what this shows is that if you're banking on functionless pseudogenes to be that truly functionless junk DNA that shows that we share common ancestry, that is not a good bet, okay? It's not a good bet to make, because people have made that bet in the past on what they thought were, locked up examples of pseudogenes. I mean, Ken Miller is going to bring his best argument to the Dover trial. That's the one he gave. We now know that that example that he gave is actually not a functionless pseudogene. I'm not saying he lied. I mean, of course, he believed what he was saying was true at the time he gave the testimony. And at that time, these papers hadn't come out. So, I'm not going to fault him for not knowing what a paper said that hadn't been published yet. That's fine. But we now know that argument he made at the Dover trial was simply wrong. I mean, it's been scientifically overturned. So I don't think that even pseudogenes are a safe bet if you're making a case for junk DNA. And that is where Michael Behe, I think, focused. Again, I don't know where he stands today, but I just don't think that the arguments I've seen for common ancestry, even from my good friend Michael Behe, are good ones. So that's what I have
some just kind of some thoughts on that whole question. I know about ENCODE, and I know that it's been a field day for ID proponents and creationists to say, hey, look, this was all predicted by creationists and ID proponents earlier on, and now it's a complete refutation of everything that evolutionists ever banked on in that realm. But I think it's more nuanced than that. I've read some by Dennis Venema. You probably know of him from BioLogos, a Christian, evangelical Christian, not just a Catholic, not a Catholic heretic, but and so he has quite a few articles on the whole question of ENCODE and pseudogenes and such. And I just don't hear that nuance coming from creationists and ID proponents to kind of engage with the kind of arguments that he's proposing. He talks about, and I don't know how to pronounce the gene for egg yolk construction, vitigelin or some vitigelinin protein that is homologous with in the same position in our genome, human genome, as it is in egg-laying creatures like birds and platypus and so forth. But you have it in the same position and a lot of the same elements, but it's obviously not. It doesn't code for any protein. So yeah, there's this question of, okay, well, yeah, even if a gene doesn't code for a protein, which was classically thought to be the main function of a gene, was to code for proteins. Since then, a lot of these what seem to be broken genes do have some sort of regulatory function, but they don't actually code for genes, and that may be the same case with the beta globin what's called a pseudogene. And that beta globin gene in rodents, for example, has a direct identifiable function for creating proteins. But my understanding is it doesn't create proteins in humans. There's a principle of exaptation where something that's already there is repurposed for something else, or maybe a lesser function. A classic example I've heard of is on the part of creationists is you've got some like dolphins that have these little pelvic vestiges, with what evolutionists call vestiges of leg bones, complete with what looks like femurs and tibia and so forth. And creationists will say, oh, well, that's used for copulation. It's used to help kind of grasp onto the female and so forth. But then you have other cases where certain, like humpback whales, occasionally, maybe every 1 in 1,000 or so, have actual external appendages that just pop out, like atavisms that pop out from external to the body of the whale. There's pictures I've seen of them. Looks like a human leg bone to me, femur and tibia and so forth. But these are atavisms that pop out of, or human tails, and every so many millions of people, babies are born with an actual external tail, complete with vertebra and so forth. So yeah, I understand the impulse to sort of dismiss the pseudogenes and say, okay, well, they do have some sort of function, they can grasp on and have copulation. But the fact is that they don't serve the same purpose that they would in something that was completely functional. And I don't think it's fair to say, okay, I think it's a non sequitur to say, oh, just because certain genes we thought didn't have a function, now we found certain genes do. That doesn't mean they all have a function. I mean, it's a complete non sequitur, and I think it's misleading to the public to say, oh, okay, well, now you would think that your position is that 100% of the genes are functional, but I think even you would think that, like, the genes that are broken in a blind cavefish, they have the eyes, they have the physical structure of the eyes, but the eyes are functionless. That you think that I think at least you would admit that the genes that code for those eyes, those broken eyes, are atavistic or vestigial, that have no purpose. You might say, okay, well, the eyes keep water from flowing into the head. Well, yeah, that has a function. Anything can be made to have a function. But let's just be realistic about it and admit that there are cases of broken genes, and go from there and say, unless you're saying that 100% of these genes are functional, what is the percentage that you would have? Is it 100%? Is that what you're claiming, or is there some 90%, or what percent are you claiming would be necessary to disprove intelligent design or disprove evolution? Is there some sort of threshold there that you're claiming? So anyway, I've said enough. I've thrown a lot out there, but I just have a lot of questions about it. I think there's more than what you're providing.
No, there's a great conversation, and whenever we start to say you're being misleading, you got to be really careful with that. All right, because you don't know what I've said, and you may not. There may be things you don't know, so be very careful. That's a very, very dangerous place to go.
Sorry.
No, it's fine.
Sorry.
Because
it feels misleading.
Well, there's a great conversation, Ken, so it's fine. Look, I have been very, very clear. I did a debate last year with Dr. Dan, who's a professor at Rutgers University. He's an evolutionary biologist, on the topic of junk DNA. That was the topic of the debate. And I was very, very clear in that debate. And I've been clear whenever I've written about this, that there is still a huge amount that we don't know about the genome. Okay. So nobody's going to claim that we know the function for every genetic element in the genome. All right. I mean, that just simply isn't true, because there's so much we still don't know about the genome. All right. So let's just get that on the table right now. There's a lot we don't know. That's true for everybody on both sides of this debate, or whatever sides you want to call it. It applies across the board, that there is a lot that we don't know, Ken. And I'm not claiming that we have discovered the function for every single stretch of DNA in the genome. However,
I'm on board with you on that. I'm just asking the question: what percentage would constitute evidence for or against creation or ID or evolution? Is there a threshold there?
I'll get to that. But you threw a lot of stuff out there, so I want to unpack this, okay? And that's an interesting question you're asking. So you talked about a lesser function. Now let's talk about the beta globin pseudogene. This is still kind of using the common junk DNA mindset that things are poorly cobbled together. Beta globin, let's be very clear. Beta globin is a functional gene, protein coding gene in humans as well. I believe all mammals have functional beta globin. The beta globin pseudogene is a copy of that gene that looks like it was a copy that, according to the evolutionary story, okay, it's a copy of that gene that at some point in the past, got made, and then it lost its function. It's just sitting there doing nothing, accumulating random mutations. So we have functional beta globin pseudogene. I'm sorry, we have functional beta globin protein coding genes as much as rats do or any other mammalian species. Yeah. So now let's talk about, why do pseudogenes sometimes look like they're protein coding cousins, but they don't generate a protein? Okay.
Right.
The reason why is because the function of many pseudogenes is gene regulation. And what they do is they produce, these pseudogenes are producing transcripts that have this very similar sequence to the protein coding version of the gene. And because they have a similar sequence, there's a chemical interaction that can happen between the pseudogene transcript and the protein coding version of the gene's transcript. And those two transcripts can interact. And those interactions are actually designed mechanisms that are there to help regulate the expression of the protein coding version of the gene. So the pseudogene is not something that lost function and then got co-opted later to help, do something. It's actually a designed part of the gene regulation system, and then it produces a transcript that is similar. Now that transcript is not capable of being translated into a protein. So that's why we call it a pseudogene in this particular case. But that transcript is capable of interacting with the protein coding transcript of the protein coding version of the gene to regulate that gene. And so this is actually why pseudogenes, not in all cases, there are some pseudogenes that may not produce transcripts, or they're unitary pseudogenes. There's not a protein coding cousin. So those are different category, but many pseudogenes are what we're talking about right now. And I'm pretty sure that the beta globin falls into this category where it's producing a transcript that's probably interacting with the beta globin protein version, coding version of that gene. And that's part of the functional reason for why it's there. So I really struggle with it's got a lesser function. It's been co-opted to do something else, because we just don't know that that's the case either. It might be doing exactly what it is intended to do. I mean, yeah, you might think that those, pelvises or whatever you want to call them on dolphins are great evidence for evolution. But at the end of the day, they're not totally functional. Human tails, by the way, I'm putting a link in the chat box right now. Human tails are not what you think they are. Humans are not born with perfectly formed functional tails. And when there are tails, they're not actually developing in the same way that a tail develops in, say, a mammal that actually has a tail. All right, they're different, and they're a developmental defect. And you can read that link. It's a lengthy discussion. I wrote this years ago. It's basically a birth defect. It's not simply genes turning on to suddenly produce the tail that the ancestor had. It's something completely different from that. And that link goes through it in some detail. Yeah.
Quick question. In this debate, kind of along the lines of what Ken says, and you may already be getting to this, but when we're talking about functionality in biological systems, the idea of there being junk or broken DNA seems to presuppose something that is not in natural selection or neo-Darwinian evolutionary theory, and that is simply that organisms have purpose. And so to argue that maybe something is junk or non-functional would seem to require that you would have to have these things having a a goal or a purpose in mind, to an end toward which they were designed and built for. But is that is that accurate? Am I making sense? Like if you're going to say it's junk or it's broken, then you're implying like a standard for which these things were supposed to design and function. But natural selection doesn't actually concede that there is design functionality to certain biological systems at all, right? Does that make sense?
I mean, certainly under the evolutionary view, the idea that there are systems that don't function are it's pretty common. What's interesting is this is more of the neutral view of evolution. The idea that there are some systems that, some mutations that will happen that are not actually being selected for. They're just there because mutations are random and they happen. And they may be messing something up, or maybe they're just accumulating in regions of the genome that don't do anything. And therefore these are neutral mutations. So this is actually less of the adaptive natural selection wing of the evolutionary, theory camp, and more on the neutralist view are the ones that really like junk DNA. They think that neutral evolution tends to bloat the genome with junk DNA. This is actually one of the original main popularizers of the term junk DNA was a Japanese evolutionary biologist named Susumu Ono in the 1970s. And he was one of the founders of the sort of the idea of neutral evolution. And very, very, very interesting, the whole history there. But did that answer your question? I'm not sure if I did answer it.
Well, I guess I'm looking like if you're measuring things in inches or feet, you need a ruler. If you're saying that, or this device that I've created functions a certain way, and to argue at all at any point that a gene isn't functioning or is broken, isn't producing sight or blood or oxygen.
You're making a philosophical question. You're telling
it's a
philosophy from
the philosophy of if we're arguing along the lines of junk or broken.
I mean, I think reproduction and survival are the purposes of. I mean, there's layers of teleology, like the Aristotle's like 5 different types of purposes or whatever. But I mean, but I think that seems like a separate conversation entirely. But
I thought he was making the opposite argument. I was thinking that the argument was that the fact that there's broken DNA would mean that there is no designer. There is no, it's not functioning. It's random, accidental, as we would expect to be if there was no creator.
Yeah, I think how that's been used by advocates of evolution are that those pseudogenes, which we can debate whether they're functional or not, but the argument is that they're inherited in a certain way from one ancestral species to another. Like we share with gorillas and chimps certain characteristics, certain pseudogenes that are constructed in the same way, and you wouldn't expect to see that under special creation if each one were in
common ancestry. Yes, it makes a good argument for that. I think, I think that you would expect if there was no designer, then you would have a lot more junk and things that didn't work correctly.
Well, no, because you have to have a certain a minimal amount of function.
Oh yeah, minimum amount, yes. But you'd have
a certain baseline. I don't want to say minimal. I should have a baseline function to be able to survive and reproduce.
Right.
Yeah.
Well, you could just say, you could make the argument that, I'm sorry.
Casey was saying that genes, things that are they're considered pseudogenes, if they're very similar across species that are separated by millions of years, and that's probably a pretty good sign that they're under selective pressure, so that they do have some sort of function. Whereas there are other genes that aren't under such pressure that show a much greater degree of divergence. And I think a greater case can be made that those are truly functionless genes in those cases.
Well, for example,
there's some species. One of Dennis Venema's arguments is there's some species of onions that have 5 times the number of DNA genes in their DNA than humans do, and neighboring species or very similar species have 1/5, 20% of that number. So there's obviously been some gene duplication going on. There's a whole genome duplication, or at least chromosome duplications. So vast amounts of DNA are copied, like wholesale, just duplication events.
Ken, did Casey kind of address what you were talking about, or do you want to follow up or redirect a little bit with him?
Well, let me say one thing real quick on the idea that we have not engaged with Dennis Venema. The reason why I've been silent for the last couple of minutes is because we responded to Dennis Venema's arguments from junk DNA so many times that I'm having to go through just dozens of hits I'm getting on Google site-specific search right now to try to figure out which ones to put in the chat box here, okay? We have definitely engaged with Venema extensively. And look, Venema is a Christian. I'm not doubting any of that. He's a nice guy. I met him once, and that's fine. Not here to challenge any of that kind of stuff. But his arguments for junk DNA have definitely, we have discussed them a lot. The onion test, what is it? The vitellogenin pseudogene, we've talked about that. We've talked about his other arguments. He would argue sometimes that the overall structure of chromosomes, the fact that you see structural similarities, what's called synteny, being conserved, is evidence for common ancestry. And I have to be honest with you. I mean, I'm not a biologist, but when I saw him arguing this, I was like, oh my gosh, like I know that the overall structure of chromosomes is extremely important for genome function. It helps determine the three-dimensional orientation of chromosomes in the nucleus, which is vital for gene regulation and genome formatting. Synteny is not just a quote unquote, whatever you want to kind of like a junk feature that is meaningless. And the fact that it's conserved is because it's the overall chromosomal structure is so important. But Venema even used that at one point as an argument for common descent, as if synteny, the overall, large scale structure of chromosomes, is not that important. And there's just a slew of literature which shows otherwise from the mainstream scientific literature. So I'll have to be honest with you, I have not found his arguments for common descent from junk DNA or various other junk features, even synteny, the structure. I've not found those arguments to be very persuasive. Now, if you want to pin me down and make me give you an exact percentage of the genome that has to be, junk before I will give up on intelligent design, I'm sorry, but that's not going to happen. And it's not going to happen not because I'm trying to dodge the question, but because these are not, these are not highly precise things where you can give a precise number on it. Okay. What I can say is this: intelligent design, I can say multiple things. Intelligent design doesn't say there can't be any junk in the genome. Okay. And this is not a dodge. I have a rational basis for this. Okay. Designed features, first of all, why does intelligent design anticipate function in the genome? Well, the reason is because intelligent agents, when they do things, they kind of do it for a reason or a function. Okay. And so like when we build a laptop or we build a cell phone or we build, a glass, okay, whatever it is, it's got a purpose and a function. So we have a lot of experience with that. However, designed features, design systems can break down over time. So if I take my, cell phone and I go put it on the top of Mount Everest for 30 years, when I come back, it's probably not going to work anymore. Or certainly, I bet my cell phone is probably better constructed than my Dell laptop. So if I put my Dell laptop on the top of Mount Everest, it's definitely not going to work. Okay, after probably just a few years. That, of course, doesn't mean it wasn't originally designed. It just means that sometimes natural processes, they can break things down and they can cause things to lose their function. And so we could see that perhaps some pseudogenes, that is exactly what happened. However, I do agree that when you have independent pseudogenes in the same position in different species, if they really are functionless, again, that's the if there. If they really are functionless, I agree with you, Ken, that common descent is a better explanation for that than common design. Okay, because it's weird that a designer would put the same feature in different, the same exact location in different species. I think common descent is a better explanation there. I'm just not convinced that the trend line of the data shows that it's safe to say that it really is non-functional. So I think that, when I look at what evolutionists have said, what percentage of the genome is junk? I found anything from 50% to 75% to 80% to 90% to 95% to 99%. Okay. I've seen so many numbers put out by the evolutionary community. And what this reflects is that there's a lot we don't know about the genome. And it kind of depends on how willing, like Larry Moran, who's a professor of biochemistry at the University of Toronto. He wrote a book a couple years ago called What's in Your Genome? And the subtitle, I think, was something like, 90% of your genome is junk or something to that effect. Okay. So I'm trying to pull this up right now if I can find this. Here we go. Title was What's in Your Genome? 90% of your genome is junk. And this was published by University of Toronto Press. So he's a big skeptic that a lot of this non-coding DNA has function. He thinks it's mostly junk. But you can find folks that say a lot less than that. So what I'm saying is that the genome is going to turn out to be largely functional. Largely means certainly more than 50%, probably a lot more than 50%, but I don't know the exact number. Okay. That's probably about as far as I'm willing to go on numbers. But I do think it's going to be high. I would be surprised if it was less than 80% functional. But again, I don't know for sure.
So, but you would deny that any cases that cross species have any are truly non-functional, because that would, for you, constitute a positive evidence for common descent. Is that a fair representation?
I'm so sorry. I may not have understood you when you said cross. Are you talking about saying other species?
Let's say an example like often quoted, the GLO or GULO pseudogene among primates. I think that that we're in a clade that shares the same pseudogene structure for that GLO gene, which in other animals is responsible for the creation of vitamin C, generation of vitamin C. But for us, we don't generate our own vitamin C. We have to rely on fruit or food or whatever that contains vitamin C to get our supply. But you would say that gene probably has some function. Is that what you're maintaining?
I would say that
evidentially.
Well, I would say that ID predicts that. I'm not saying we know that. I'm willing to let the evidence fall wherever it falls. Okay. Mm-hmm. I will say this. There have been some studies, they're kind of old, and some of them older than others, that have found elevated amounts of vitamin C in utero beyond just what the baby should be receiving from the mother. And some folks have proposed, and again, this is a hypothesis that I don't think has received adequate testing yet. So I'm not saying I know this is true. I want to be careful here. But I think that there is an interesting hypothesis out there that the vitamin C pseudogene, quote unquote, or the GULO pseudogene, as you correctly called it, Ken, might be active in utero. And then it turns off in adult. We often, some people become lactose intolerant later in life because certain genes get turned off and silenced. And that may be something somewhere in that spectrum along those lines that's going on. And so again, this is a hypothesis that I don't think has been adequately tested yet, but it's something that I think is an interesting question worth asking. And I'd love to see if that happens.
You're saying that there's the possibility that it might have a function, but that just so I'm clear, it's not a knock against your hypothesis. I'm just saying that there's nothing been proven yet for it. It's a hypothesis still. Is that correct?
Well, nothing in science is ever proven, but there is some evidence, and that they have seen elevated amounts of vitamin C in utero that seems to be beyond what you would expect from the mother giving to the baby alone. Okay. So this is not just coming out of left field. There's some evidence for this. What needs to be done is to actually, study that question in more detail, maybe I mean, don't ask me how to do it. But I mean, I could speculate, but to actually test it experimentally. But I guess what I am going to say very definitively right now is that the vitamin C pseudogene is exactly where the beta globin pseudogene was 15 years ago. All right. We really don't know that it's non-functional. We really don't know that. It might turn out to be non-functional, but we really don't know that. It has not been studied adequately yet to make a determination as to what is going on with it. And so to the extent that people bank on the vitamin C pseudogene as evidence for common ancestry, that is no different, in my opinion, than what Ken Miller and Eugenie Scott did, banking on the beta globin pseudogene as evidence for common ancestry. It is not a safe bet to make, and these bets have been shown, even what people thought were very safe bets in the past, were shown to be wrong. And so I am very, very hesitant to do that.
I just Googled that one, and it said the elevated vitamin C levels in pregnancy are from, they're from placental transfer from the mother. There's no evidence that they're coming from any sort of natural, the uterus is actually, or the baby is actually generating it.
Well, if Google AI said it, then it must be true. I'm telling you, I've seen some papers.
I'm just saying that there is another perspective. You put
of course there is. Of course there is. I mean, that would be the alternative view. Of course. I mean, I'm not saying people are crazy, and I'm not trying to hide anything. I'm saying that it's also not crazy to say that this pseudogene might be functional. So if this is like what your worldview is staked on, I wouldn't do that, because other people have bet on other pseudogenes that turned out to have very important functions. And I don't know what's going to happen with this one in the future.
So if getting to like whales and such, I mentioned the atavisms, but also there's a lot of things that happen during fetal development that suggest that, for example, fur grows liberally on the fetus in the womb, and then it gets shed before birth, so that it comes out, with a smooth skin that can swim in the water. Things like that suggest to me. I mean, they don't prove, but they suggest that. You talk about copy paste. Human designers who have constraints on them. We have. It's easy for us to copy and paste, but if this intelligent designer, and here we get into theology, if the intelligent designer is, omniscient, which I don't think you would deny, I'm allowed to talk theology to somebody who holds a certain.
Oh yeah, of course, it's all good, man. You're good.
So that's my question. Is that like, if I were a human, I might want to copy and paste so that I could reuse what I've already got. But if I'm a limitless God who can do anything, why am I copying and pasting in the genes that cause hair in fetal development, that suggest some sort of ancestry? And why would
Can I speak to that real quick? Yeah. So isn't Google amazing? Like, it can instantly make you an expert in something you knew nothing about like 5 minutes ago, but like, if we want to play the I Googled it game, I just Googled it, and the clevelandclinic.org says that the soft, fine hair covering a fetus while inside the uterus helps protect the fetus and keep it warm during development. Okay. So it has a function. All right. It's not just there necessarily because of our ancestors. We can play the exaptation game and the blah, 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 but it's there for a reason. Okay. So I'm not convinced that that's a great example.
Hey guys, in just a second, I'm going to ask Daniel Ray if he will share about our October guest author and book. But before we do that, just to go back one more time to talk about, is ID merely a fundamentalist Christian Trojan horse trying to smuggle in theology and Christianity? One of your colleagues has ended about maybe 5 or 6 years ago in the book club. We did. David Berlinski, we did his book, The Devil's Delusion. And so here's not your typical Christian fundamentalist who's, could you kind of address his background and where he's coming from as not a Christian fundamentalist who is a proponent of ID at Discovery Institute?
But yeah, absolutely. And before I say, I want to say, Ken, you've raised some great arguments. You've put up a very good argument, and I appreciate your thoughtful comments. and what you said. And I just want to say thank you. I've enjoyed the conversation.
It's a good conversation.
Yeah, really.
And
really
always has the best questions.
Yeah, you've clearly thought this through a lot, and you're coming at me. I appreciate that, and good arguments. So, so David Berlinski is a fellow at Discovery Institute. I believe his PhD is originally in philosophy, but he spent many years teaching math. He's got a very strong mathematics background. My understanding is he's basically an agnostic Jew. I mean, if you get to know David, he definitely is not, Mr. Kosher, like that's for sure. I mean, he smokes, he curses. He's a lot of fun to hang out with, actually. Like it's definitely the kind of guy you want to go have a beer with. And I've gotten to do that a few times and really enjoyed getting to know him over the years. Anyway, but he is sympathetic to intelligent design and also very much a critic of Darwinian evolution. And what's interesting is that if I recall correctly, what kind of set David down the pathway of being a Darwin skeptic was his mentor. I'm not sure it was PhD supervisor. I don't want to say off the top of my head. I'm not totally sure, but his mentor was a mathematician named Marcel Paul Stutzenberger, who was at this famous meeting of the Wistar Institute called Mathematical Challenges to Neo-Darwinism back in the 1960s. And you guys, if you follow, creationist lore, everybody talks about this, right? I mean, the Wistar Institute meeting in the 1960s. But this was when biologists first began to ask the question, okay, we now understand a little bit about how, genes work, that you've got to have nucleotides in the right sequence to give you the right codons, to give you the right amino acids in the right order, to give you a functional protein. They were just starting to come to terms with that. And they were asking the question, well, can the mutation selection mechanism do that without degrading function? And one of the main points that was made there, and this was not at all a religious thing, this was very much top experts from different institutions, was, computer programming was also getting started. And, you put an error in a program, and that's going to degrade function. Or you put a random change to a program, I should say, not an error, but a random change to a program is going to degrade function. And they were expecting that something similar could happen with genes. And Marcel Paul Stutzenberger was one of the mathematicians who was there at the Wistar meeting. And I think that he had a big influence on David Berlinski. Anyway, he's written quite a bit against the neo-Darwinian model, also the origin of life. He's also written about the Big Bang, and he's just an interesting guy, very, very dynamic thinker. And he's written a lot of books. I've read a couple of them, but if you enjoy, technical writing with a lot of flair, then he might be up your alley. I don't know.
Thanks so much. And before we say goodbye to you, I just want to get Daniel an opportunity to tell us what's going to happen in October.
I have never met this man, John Campbell. He's an attorney in Memphis, Tennessee. He approached our book club on Facebook a couple of months ago, and I followed up with him through email, and has written a couple of books. This is a smaller version. Why Christians Are Wrong About Jesus, and he'll be our guest next month. So he's a trial attorney, lawyer, was a former Christian in college, lost his faith in college. He's also a part-time magician. I've never met him. I've only chatted briefly with him through email. He seems like the book doesn't have a polemical tone. I got it on Kindle and was looking through it. But John is interested in Christianity, still talks about it. Couldn't find any videos or anything online about him. He does have a website, jwcampbell.org. You can find out more about it, but that's our book. It's very inexpensive. You can get it in paperback and Kindle, but that'll be next month, October the 2nd, 7 to 9 p.m. on first Thursday of next month.
I think he joined us briefly. I saw him.
He was here. Yeah. He was here briefly. But anyway, that's next month. And it sounds like I was looking at the chapters. I mean, he goes into, Isaiah 53 and certain problems that traditionally come up in terms of reliability and, alleged contradictions in the Bible and those kinds of things. But don't know if he's a mythicist. Don't know where he is on that spectrum. Did Jesus exist? But we'll find out.
It may be a big mistake to have two attorneys in a row and try to tap down all the lawyer jokes, but we'll do our best. Do you have any final advice for the crew here, Christian or atheist? Casey, any words of wisdom?
Well, I just want to say that what you guys have going here is something really cool and really special, which is probably why you don't have a bigger crowd, because it's so great to have, folks with different views getting together and having these conversations. I mean, Ken, Bill, all of you guys, I've really enjoyed the thoughtful questions and the good and the very fair questions, frankly, that you've been asking. This is what's wrong with our society today, right? I'm sure we're all going to agree on this, that people don't interact enough with folks who think differently than they do. Or if they do interact, it's just to basically, say 4-letter words towards them like Professor Dave does, and not really engage, I think, with what people are actually saying. So this is a symptom of our society, unfortunately, today, that discourse is degraded. And you guys are a bright light that's showing that you can still have friendly discourse. And I really appreciate that. And I just hope you guys will continue doing this, because this is important and this is showing people the way forward. And I really admire what you guys are all doing here. Any
other books in the oven right now?
I do have books in the oven, but I never have time to write them because every day is the same Groundhog Day for me. I get up and I've got all this admin work to do. And if I can get the admin work done, I get to do some of my own writing. And lately it's been like 1 out of 14 days that I get a little time to do some writing. It's just brutal, you guys. I enjoy the admin work. I get to manage a research program for intelligent design. It's a lot of fun. I get to work with a lot of great people, but man, I just wish I had more time to write. I am writing a book right now about what is the theory of intelligent design. I'm hoping to get some time before the year is over, maybe to finish it. We'll see what happens.
Well, please come back when you do.
If you're inclined to pray for me, pray that I can finish the book. And if you're not inclined to pray, do whatever you do to help me finish that book.
Well, that's why the publishers give you advances, so they can hold that over your head.
Well, in this case, I already work for the publisher, so it's just I got to get the day job done in order to get to the book. So thanks, you guys.
Thanks so much for being here. You've been delightful, added to our conversation. Really appreciate you, and hope to see you again in the not too distant future.
I would love that. Thank you, Daniel, and thank you, James, for inviting me. Really appreciate it. Great to see you guys.
Bye-bye, everybody.
Bye. Thanks, Case.